In this video, we will learn how to write an assembly language program to perform the addition and subtraction of two numbers using micro and procedure. In this program, we have written this dot model small. So small indicates that our all data and our all code are stored within only one segment. So in this dot data, in that data segment, we have declared these two numbers, that is M1 and M2. So M1 consists of addition is and M2 consists of subtraction is, and our string is ended with that dollar sign. We have declared this number as M1 DB 10, 13. So we are declaring it as string addition is. But we have to write here 10, 13. Once we are displaying this addition is on your console, that time we can check that our data will be printed addition is, and it will display one cursor here. So that purpose we have to take this 10, 13. Now we have taken this M2 string it as db 10, 13 subtraction is. We have to perform addition and subtraction of two numbers. So that's why we have to require two numbers, that is two 16-bit numbers. And we can declare these 16-bit numbers with the help of this DW directory. So we are writing here num1 DW 5347H. Then num2 DW 121342H. After performing the addition and subtraction, we require one variable that is used for storing the result of the operation. So I am writing here result DW question mark. So question mark indicates that it will store the value after performing some operation. Previously it is 00. Now check that in that code segment we have written this micro statement. So micro can be used for writing when we require a group of instruction again and again, and when these instructions are small, that time we are using the concept of that micro. So how we can declare the micro? First of all, name of the micro, that is DISP, then this micro keyword, that is micro, and our number of parameters. So we require only one parameter, that's why we are writing here XX parameter. And these three group of lines are there, that is for displaying the data, that is addition is, on your console. Then we are ending the micro with the help of this end emp directory. So this is our micro, and we have written with this micro keyword. Now once our actual program execution will be started, we are writing here dot startup. Then our all data segment and all code segments are initialized and our program execution will begin. So here we can call this micro with the help of this name of the micro, that is DISP, and our argument. Our argument is M1, and our M1 consists of addition is. Once we are calling the micro with the help of argument, the values of M1 will be assigned to the XX parameter. Now our XX parameter consists of our addition is. So our XX variable consists of the data addition is, and that data we are printing on your console. So how we can print the data on your console? With the help of this DOS interrupt. So we require the DOS interrupt, that is 09H. So we have to move that value into age register. So after moving that value into age register, we require the statement, that is load effective address, and then we require the DX register, and we are copying the parameter XX value into our DX register. Whatever the data we have to print on your console, first of all, we have to move that data into compulsory in DX register. Then with the help of integer 21h, we can printing the data on your console. So we have write this three statement in our micro. So these are the three statements that are written in our micro. So whenever we have to print addition is, whenever we have to print subtraction is, that data will be printed with the help of this micro. So these are the three small number of statements are there, and we can use this micro for writing a group of small instruction. So now check that after calling this dispm1, our data will be printed on your console. So now we will check this output on our emulator screen. Now see here, our program execution will begins with our dot startup. Then I'm clicking on that single step mode. So it will be redirect to the DISP M1. So whenever we are calling this DISP M1, this all micro code, that is DISP micro XX, move h, 09h, load effective address dx, xx, integer 21h, and end them. This all micro instruction will be expanded in our main code of our program segment. And here you can also see that this is the code, and that will be expanded here. So I'm executing this one, and this value of M1 will be there in that addition is, and that will be loaded, and our micro instruction will be executed. So here you can check that whenever our micro will be executed, that time this yellow highlighted part will be there only with the DISP M1. Our control is not redirected with the micro instruction. So what will be happen here? This all the lines are expanded in our actual program. So here you can see that this move h, 09h, move dx, 0000h, that is integer 21h. These three lines are executed here. If I'm clicking on that single step mode, and you can see that once I'm clicking here, it will be redirect to the next line. Again, it will be redirect to the next line. So this micro will be executed as like manner. So now you can see this addition is displayed on your console with the help of these three statements. So here these three group of statements we are writing in our micro, and whenever we are calling to the micro, that time our control will not be redirecting to the micro definition. These three group of statements are expanded here in our actual main code of our program. So this is the first line, this is the second line, and this is the third lines. These three statements are expanded here when we are calling to the micro. So our num1 is equal to 5347, and we are adding this ax comma num2 is equal to ax is equal to ax plus num2. So our ax is equal to 5347, and our value of num2 is equal to 1342. So after performing the addition, it will become 6689, and that result will be stored into our accumulator, that is AX register. Now the contents of our AX becomes 6689. So the next line is move res, that is result comma AX. So whatever the contents are there in AX register, that will be copied it into the result variable. So our result variable becomes 6689. Now we will check these contents on our emulator screen. So here check that we are clicking on that single step mode of operation. Our AX becomes 6689, and now our value of AX will be copy it into the result variable. So our result variable becomes 6689. That value will be printed and that will be displayed on your result variable. Now we are taking this value only our result variable. We have not printed this data on your console. Our console is only display addition is, and the value is not printed here. So how we are printing that value on your console? So we have used this procedure, that is DISP1 procedure in our program. So this is the whole code that is written for our procedure. So how we can declare the procedure? Name of the procedure, that is DISP1, then proc keyword, and which consists of a large number of instructions that will be required to print the data on your console. Then our procedure will be written with the help of this return keyword, and then our name of the procedure, that is display1, and end of the procedure. So it will indicate that our procedure code will be ended. So this whole group of instruction will be written it as for printing this 6689H on your console. So see how we can call the procedure. With the help of this call instruction and name of the procedure, we can call the procedure. So I'm clicking on that single step mode of execution, and our control, you can check that our control will be redirect to the procedure code. So here the value of our result is 6689. So I'm taking this value here. Result is equal to 6689H. And we are copying this value into AX register also. So I'm writing here AX is equal to 6689. And how this value is stored it into our AX register? Our AH is equal to 66H and our AL is equal to 89H. So I am putting here AH is equal to 66H and our AL is equal to 89. Now, what is the next statement in our program? First of all, we are going with that DISP procedure 1. This is our procedure code. The whole group of instructions are written for executing this procedure. So the first one, the value of result variable, we are copying it into the BX register after writing this move BX comma result. So what is the contents of our result? That is 6689, that we are copying it into the BX register. So I'm putting here 66 into BH register and 89 it into BL register. So what is the next instruction? And BH comma 0F0H. So what is my contents of BH? That is 66H. And we are performing the AND operation with 0F0H. So this is your 66 and this is your F0, and we have to perform the AND operation. So for performing the AND operation, we require the number in binary format. So what is the binary for 66? We can write it as in the form of BCD. So 66 is equal to 0110 and 0110. And what is the binary for F0? 1111 and 0000. So we are ending with that F0, that is 0F0. So we can discard this 0 and we can only consider this F0. After performing the AND operation, we will get the value, that is 00 is equal to 0, 10 is equal to 0, this is also 0, this is also 0. If both the numbers are true, then your output will be true in case of AND operation. So you will get here 0, 1 is equal to 0, then 1, this is also 1, and this is also 0. So you got the output 0, 1, 1, 0 and 0, 0, 0, 0. So your value becomes 6, 0. And that is the output you got after performing the AND operation. So whatever the output you got, that will be stored it into BH register. So your value of BH becomes 60. So this value will be overwrite with your 60H contents. So previously the contents of our BH register is 66H, and after performing the AND operation it will become 60H. So why we are performing this AND operation? First of all, we will consider this content that is 66H. So what we have to perform? We have to do with the 60 plus 6H. That addition we have to perform. That's why we have to perform the AND operation with that first bit, that is F0. So we are taking F here in the form of higher nibble of bit, and this is our lower nibble of bit. This we can consider it as 0, 0, 0, 0. So we got here 60 and we will put it into the BH register. So now what is the next step? The next instruction is move CL, 4H. So what is our CL? It will store it as 04H. Now next one, the instruction is SHR BH, CL. So after performing the instruction, that is SHR, then BH, CL. So what is our contents? SHR. What is the contents of now BH? 60, then comma 04H. So you have to shift this 60 4 times with the help of SHR instruction. So for 60, what is the binary for 60? That is 0, 1, 1, 0 and 0, 0, 0, 0. So we have to rotate this number 4 times on the right side. So what will be the value? That is our 0, then 0, this is also 0, and this is your 0. Then again this is 1, this is 1, this is 0, and this is 0. So you have shifted this number first time. So how many times you have to perform this operation? Total 4 times you have to perform this operation. So this is the first iteration. Now we are going with that second iteration. So here is also 0, then 0, again 0, then this is 1, again 1, then 0, and 0, and this is also 0. In the third time, we got this is 0, this is 0, then 1, then 1. Again, this is 0, 0, 0, and this is your 0. On the fourth time, we got the value that is 0, this is 1, this is 1, this is your 0, then again 0, 0, 0, and you got this 0. So what value you got? 0, 0, 0, 0 and 0, 1, 1, 0. So after performing the fourth iteration for shift rotate instruction, that is SHR instruction, we got the output 0, 6. And that value will be stored into our BH register. So now our BH becomes 06H. So this value will be updated and it will store the new contents, that is 06H. So this is our BH is equal to 06H. So what is the next instruction in our program? Add BH, 30H. So why we are adding with that 30H value? Now we got the value of BH is equal to 06H. And we have to print the addition of our two numbers that we got, our result that is 6689H on your console. So how this value will be printed on your console? First of all, 6 will be printed on your console, then this 6 will be printed on your console, then 8 will be printed, and then 9 will be printed. One by one we have to print all these elements. So now first one we have to print this 6 on your console. So how this 6 will be printed on your console? Directly we cannot print 6 on your console. First of all, we have to add this 30 value into your BH register. So our previous contents of our BH are 06H. So after adding 30H, it will become 36H. Then we have to move this value of our BH into DL register. Directly we cannot print a value on your console if it is stored in AX register, if it is stored in BX register or CX register. Compulsory we have to copy the value of our BH into our DH register, yeah, or else in DL register. So basically we have to use this DX register for taking the data on your console. So this number is 8-bit. So is this okay? We can move it into DH or DL, right? So we are moving the value it into our DL register. So that's why we have written the statement that is move DL comma TH. So what are the contents of our BH? That is 36. So this 36 will be copy it into our DL register. Now what two statements we can write for printing the data on your console? That is move age comma 02H and integer 21H. So with the help of these two statements, our data will be printed on your console. So this 36 will be displayed on your register, that is DL register. But once it will be printed on your screen, it will be shown as 6 on your console. Now we will redirect to our emulator screen and we will check how this group of statement will be executed on your console. Now check that in our emulator screen, we are going with that single step mode of our operation. Our value of our result is equal to 6689H and that will be displayed on our variable screen. So BX value will be moved into the BX register, result value will be moved into the BX register, that is 6689H. Then we are ending with the BH value with the 0F0. So we will get this value BX is equal to 6089. So we are considering only this BH register, that is 60H. Now the counter value will be updated with the 4. Then after shift rotate instruction, our value of BH becomes 06 that we have already seen on your whiteboard. Then we are adding this 30 into our BH register. So our BH becomes 36H. Now we are copying this value into our DL register. So our DL becomes 36H. And here we have to check that our console. So what is our console? How it will be printed? With the help of this 02H interrupt. And we are copying this H is equal to 02H. And after using this integer 21H interrupt, the 6 will be printed on our screen. Now we will redirect to the next part of our code. So this part of code will display this 6 on your console. So now we will check how this will be printed on your console. So previously our result variable is 6689H and we will keep this variable as it is as we are not performing any operation on that result variable. So again we have to copy the values of result variable into our BX register. So our BX consists of 6689H. So now we have to perform the AND operation with our BH register. So we have to consider only this 66H here. So we are performing this AND operation with our BH register with 0FH. So what is the contents of our BH? That is 66, and we are performing this AND operation with 0FH. So first of all, before performing the AND operation, we have to convert it into the binary number. So our binary numbers are 0110 and again 0110. So our AND operation is performed with the 0FH, that is 0000 and 1111. And after performing this AND operation, what will be our value? If both the values are 1 and 1, then you will get the value 1. Otherwise, the value becomes 0. So we will get our result, that is 0, 0, 0, 0 and 0110. Okay, so this is our result. So we will get our output 0000 and 0110. So our output is 06H, and that value will be displayed on your BH register, and it will be stored it at BH register. So our 66 will be replaced with 06H. Now we don't have to perform the shift right operation because already we got the value 6. So what we have to do with that 6? We have to print that 6 on your console. Then first of all, we have to add the 30 on our BH register. So after adding the 30 on our BH register, it will become 36H. And now we have to print this 6 on your console. So that's why we have added here 30 on our BH register. So for printing the data on your console, we first of all, we need to copy this value on our DL register. So we are writing here move DL comma BH. So this value will be copied into DL register, and after writing this two group of statement, that is move H comma 02H and integer 21H, that is our DOS interrupt. With the help of this DOS interrupt, our 6 value will be printed on our screen. So now we will check this data on our emulator screen. Previously, we have print this 6 on our console. Now we are printing this 6 on our console. So now let's redirect to the emulator screen. So check this one. We are with the single step mode of our operation. The result variable will be copied into the BX register. And our BX becomes 6689. Then we are ending with the BH comma 0FH. That is 66 will be ended with our 0FH value, and it will become 06H. Now we are adding this 30 into BH register. Then our BH will become 36H. Again, we are copying this value into our DL register. So our DL become 36H. Then we can display this value with the help of 02H interrupt on your console. So check this one. Our 6 is again printed on our console. So in that part, we have displayed the 66 on our console. Now we have to display the contents of 89 on our screen. So now let's check how we can print this data on our screen. Now we will see the next part of our code. So in this code, that is movebx, that is result. So value of our result variable is 6689H, and we are copying this result variable into the BX register. So our BX register becomes 6689H. Previously, we have worked with our contents of BH register. Now, everything we will perform the same operation that we have printing the 66 on our console. The same operation we will carry forward with our contents of BL register. So the contents of our BL register is equal to 89H. So see here, the next statement is and BL comma 0F0H. So 89 is ANDed with our F0H value. So what will be the binary for 89? So 89 is equal to, that is 1000 and then 1001. That is the binary for our 89. That is BCD number we have written. That is 1000 for 8 and 1001 for 9. And for F0, we are writing here 1111, then 0000. And after performing the AND operation, we will get this higher nibble, that is 1000, and these all are 0 because we are ANDing with this 0000 with our lower nibble. So after performing the AND operation, we will get our output, that is 80, and that value will be stored into the contents of BL register. So previously the contents of our BL is 89, and after performing the AND operation, it will become 80H. So now what is the next statement of our code? That is move CL comma 4H. So the contents of CL becomes 4H. Now we have to shift right our BL contents with CL times. So how many times we are shifting? That is 4 times we are shifting our 80 on the right side. So first of all, I am writing the binary of this 80, that is 1000, then 0000. And we are performing this shift right operation. Then we will get here 0, then 0, then 0 and 0. So this will be shifted as like this. Again it is 0, then this is 0, this is 1 and this is 0. So I have shifted on the right side first time. This will be performed 4 times in our operation. So after performing the 4th iteration, we will get this value 0000 and 1000. So we will get this value as a 08H. So how this value will be stored in our BL register? After performing the shift right operation, the contents of BL becomes updated and it will become 08H. So now we are storing this contents of BL is equal to 08H. Now what is the next statement? We are adding the contents of BL with 30H. So this 8 will be updated with 38H. So 30 is added in our BL register. Now we have to copy the contents of BL into our DL register for printing the data on our console. So 38 will be shifted and it is copied it into DL register. After writing this move DL comma PL instruction. Now the next statement is move age comma 0 to h and integer 21h. So by using these two lines, our 8 will be printed on our screen. Now we can check this output on our emulator screen. So here we are there in the move bx comma result variable, this instruction. After executing this instruction, the bx value becomes 6689h. Then we are performing the AND operation, that is BL comma 0F0. Then after performing the AND operation, it will become 80H. Then we are moving the contents of CL is equal to 4. Then SHR BL comma CL. So the contents of BL, that is 80H, will be shifted on the right side 4 times and it will be updated as 08H. Now we are adding the BL comma 30 and it will become 38. So now the contents of BL is equal to 38H. So we have to shift this value into our DL register, so that will be printed on our console. So now 38 will be shifted in our DL register after writing the move DL comma BL instruction. Now with the help of 0 to H interrupt, the data will be printed on our console, that is there in the DL register. So see, the addition is 668 will be printed here. Now we have to print the 9 on our console. So now let's move to the next part of our code. So in that code, we have written the move bx comma result variable. So the value of our result variable is 6689H. So this value will be copied into the bx register. So it will become 6689H. Now we will perform the AND operation with the BL, 0FH. So the contents of BL is equal to 89. So we will write the binary for it, that is 1000 and 1001. And for 0F, we can write it as 0000 and 1111. So after performing the AND operation with 0FH, we will take the data that is given in the lower nibble of our 89. So we will get the value after performing the AND operation is 0000 and 1001. That is 09H. And this 09H value will be copied it into the BL register. So the previously the contents of BL is equal to 89, and after performing the AND operation it will become 09H. Now we have to print this value on our console. So 09H will not be printed on your console. We have to print 09H. But here we have to add 30 it into the BL register. So it will become 39. So that is the hexadecimal value of our 9. Now we have to copy the contents of our BL into our DL register. So that's where we have right here move DL comma BL. The contents of BL will be copied into the DL register. Now with the help of 0 to H interrupt, that is move H comma 0 to H and integer 21H, the value of our contents of 39, that is the hexadecimal value of 9, and that we are printing 9 on our console. So let's check with our emulator. So here we are with the integer 21H previously. We are going with the single step mode of our operation. Then the value of our result will be stored into the BX register, that is 6689H, and we are considering only this BL part. Then we are performing the AND operation BL comma 0FH, and it will become 09H. Then we are adding here BL comma 30H, and it will become 39. And now we are copying the values of BL into the DL register. So now our DL become 39H. So after using the move H comma 0 to H interrupt and integer 21H, our data will be printed on our console. So let's check that our console is the 09H will be printed on our screen. So now we have printed the 9 on our console. So our whole output will be printed here and the data will be displayed it as 6689H. Now we are with the return statement of our procedure. So what this can be do, the return statement, it will return the control where the procedure is called. So here in this program, we have called this procedure display 1 in that line number 23, that is call display 1. So after executing this call display 1, our control will be redirect to the display 1 procedure, that is line number 32. So whenever we are performing this return instruction, check that our control is redirect to the next line of our code, that is on the line number 25, because our 24 line is blank. So it will directly redirect to the line number 25 where our procedure will be called. So after execution of our procedure, we have to return the control to the next line of our code. So that's why we are using this return statement in our procedure end of the program. Then we are ending the procedure with the DISP1, that is name of the procedure, and endp, that is the directive which is used for ending the procedure. Now we are redirecting to the next line of our code, that is DISP message 2. So this is also our micro call, that is DISP is the name of the micro and M2 is the parameter that is given for our subtraction each message. So after calling this DISP M2 micro, our micro lines, that is 3 line of our micro instruction, that will be expanded in our main code. So these 3 lines will be expanded, that is in our main code, and that will be executed. So check that after executing this code, you can display the subtraction each, and that will be printed on our console. Now we are copying the value of num1 into AX register. Then we are copying the value of our addition. Then with our AX comma num2, we are performing the addition previously. Here we are performing the subtraction. So check that the value of num1 will be copied into AX register. So it will become 5347. And here, these are the variables that are stored in our variable directory. That is, variable num1 is equal to 5347, num2 is equal to 1342, and the result variable is 6689. Now it will be updated after performing the subtraction instruction. So subtract AX comma number 2. After executing this instruction, it will execute it as AX is equal to AX minus num2. And this parameter will be updated here and your value of result will be updated. So the contents of our AX will be 4005 and that we are copying it into the result variable after writing the statement, that is move result comma AX. So check that our result variable here, it is updated. Now we are again going to the call display1 instruction. So this instruction will redirect to the procedure code. So this display1 will be called as a procedure with the help of this call instruction. And we are moving to the procedure code. And after execution of this procedure, it will display the 4005 on our console. So the same procedure will be followed for printing the 4005 message on our screen. So check that the result variable will be copied into the BX register. So BX becomes 4005 and then we are performing the AND operation with the BH part and F0 will be ANDed here. So it will become 40. Now the CL will be copied into the register, that is 4 will be copied into the CL register. Then we are shifting the right bit BH comma CL. So this 40 will be shifted 4 times with the counter 4 times and it will become 04. Now we are adding the 30 on our BH register and it will become 34. Now we have to copy this 34 on our DL register. So now our DL becomes 34. So now we have to print this 34 on our console. So how we will print this 34 on our console? 34 is the hexadecimal value of our 4. So we are adding this 34 and with the help of 02H interrupt, this 4 will be printed. Now we have to print 0 on our screen. So again we are copying the result variable into BX register, that BX becomes 4005. Then we have to perform the AND operation, that is BH comma 0H. So after performing the AND operation, it will become 00H. Then we are adding 30 on our BH contents. So it will become 30. And we have to print this data on our console with the help of this DL register. So for that purpose, we have to copy the contents of BH into our DL register. So now we are adding this 30 here in our DL register, and with the help of 0 to H interrupt, this data will be printed on our screen. So now we have printed the contents of BH register on our screen. That is 40 will be printed on our screen because we have copied the value of result variable into the BX register. So again we are copying the contents of result into the BX register and it will become 4005. So now we have to work with our contents of BL register. So the contents of BL register becomes 05. So now after performing the AND operation with F0, it will become 00. Now we are copying the contents of 4 into our CL register, and after performing the shift right operation, it will again become 00. Now we are adding the 30 with our contents of DL register. So it will become 30 and we have to copy this 30 in our DL register. So it will become 30H. And that data will be printed on our screen. So check that our 0 will be printed here. Now we have to print a 5 on our console. So again same procedure we have to follow. The result variable will be copied into the BX register, that is BX is equal to 4005. Then again we are performing the AND operation with this 05, that is 0FH, and we are taking the lower nibble, that is 5. Then we are adding the 5 with 30 and it will become 35. Then this 35 will be copy it into the DL register. So this DL register becomes 35 and this data we have to take it on console after writing the move age, 0 to h and integer 21h. So this data will be printed on our console. So successfully we have printed the addition is and subtraction is the value on our console. Now we will redirect to the return statement, and after writing this return statement, it will move to the next line of our code, that is jump last. So after using this jump instruction, it will redirect to the last label. So this is our last label and our code will be going to be exited with our writing dot exit statement, and our program will be ended here and it will shows the program will be terminated successfully. So with the help of micro, we have print addition is and subtraction is, and with the help of procedure, we have print the output of addition is and subtraction is, that is the number 6689H and 4005H. So in this video, we have learned how to write an assembly language program with the help of micro and procedure. So check in this program, we have write the dot startup for our initializing all the data segment and the code segment and starting the execution of our program. And here we have write the dot exit statement for terminating our program. And with the help of end, this is the end of our program. With the help of dot exit, we are calling the DOS interrupt, that is 4CH interrupt. So with the help of dot exit, we are terminating our program and this will be called with the help of label last. And here we are calling the label last with the help of this jump instruction. So this is our jump instruction and we have write this label last. So in this program, we have learned the concept of procedure, concept of micro, different jumping instruction, calling instruction, arithmetical instruction, as well as data transfer instruction.